Hey everybody, today we'll try to solve one problem of impulse. That is a very interesting problem. But before proceeding to the problem solving, we'll see what impulse is. As you all know, impulse means a huge amount of force acting for a very short duration of time. If the amount of force is acting to a body or to a mass for a small time, then this integration of f dt is called the impulse. Then how to measure the impulse? We cannot, if we do not know the exact time of contact of the force, then impulse can be measured by calculating the change in the momentum. So that means final momentum minus initial momentum, that is called impulse. Now as an example, we'll see, suppose one particle of mass m is moving in this direction and a bat hits the particle or this ball in this direction. But that time of contact between the ball and the bat is very small. Let's say delta t, and the amount of force also is very high, that is not known. Then the amount of impulse is f into delta t, but that measurement will be the change in the momentum of the ball. That means if after this contact or after this collision, if the ball gets some velocity v2 in the leftward direction, and if initial velocity was v1, we can tell that the amount of impulse is change in the momentum, that is m of v2 plus v1 here in this case. Okay, and one more concept of impulse we'll see, that is if the force is applied in this direction, in the leftward direction, it will only change the momentum in this direction. If the ball is traveling with some velocity, suppose v1 in this direction, and if somebody hits the ball with the bat in this direction, then the ball eventually will get some velocity in this direction. That means this is the momentum direction, and then this component of the momentum will only get reversed. We'll try to see the problem right now. The question is, a particle of mass 1 kg is attached to a string of length 5 meter. The string is attached to a fixed point O. It is released from a position shown in the figure. The impulse developed in the string you have to calculate, and the velocity of the particle just after the string becomes taut. That means what? Try to see. Let's say this is the cart and this is the string right now. Right now this length is given as 3 meter, but the total length of the string is just 5 meter. So if we release this ball from this position, it will, due to gravity, it will go downward. Up to what point it will go downward? Till the time the string will become taut. That means it gains the length of 5 meter. Till this point the ball will go downward. That means how much vertical distance it will cover from this position? This is 3. This hypotenuse is 5. This height will be root over of 5 square minus 3 square, that is 4 meter basically. So what will be the velocity of the ball if it covers the 4 meter vertical distance? As you all know from the equation, v equal to root 2gh, 2 into g into h. That is root over of 2 into 10 into 4. That is root over of 80 meter per second. That is the velocity of the ball just before the string becomes taut. Now taut means what? When the string will be taut, just before that the velocity of the ball is root over of 80 meter per second in the vertically downward direction. Right now the string is becoming taut. That means what? That means the string will develop a tension in this direction, but it is like a jhatka, right? So that means there will be this tension will be developed for a very short duration of time. The impulse will be developed is integration of ddt. It is J. So what will it do? It will consume the impulse along the direction of the string. So if this particle is right now having the downward velocity of root 80 meter per second, we can resolve this velocity in two components. One is along the string and one is perpendicular to the string. So this along the string component will be consumed due to the impulse developed. So the only velocity will be there, this component of the velocity, this perpendicular component of the velocity. So that means if this is the angle theta, so how much distance is covering? I told 4 meter vertical distance is covered. This is 3. So what is the angle theta value? Tan theta is value is 3 by 4. That means cos theta value is 4 by 5 and sin theta value is 3 by 5. So this along the component of along the string, the component will become 0 due to this impulse developed. So that means this impulse will change the momentum of this particle in the direction of the string, along the string. Okay. So the only component will be available for the particle will be this direction. This direction. So that means this is theta means this is theta. That means this is 90 degree minus theta. This is 90 degree minus theta. That means this is also theta. That means root 80 sin theta component will be only existing component of the particle after just after the string becomes taut. So what will be the velocity of the particle just after the string becomes taut is root 80 sin theta. That is root over of 80 into sin theta value you already know 3 by 5. So what is it? 12 by root 5 meter per second. Right now it is asked that in the first question. So second part of the question is already solved. This is the second part of the question. The first part is what? The impulse developed in the string when it becomes taut. So what is the impulse developed in the string? What the impulse will do? This is the string is 80 meter per second. What I told that along the direction of the string, this velocity will become 0 because of this impulse. So integration of t of dt. So the impulse developed in the string will be the change of momentum along the direction of the string. Of the string. So this is root 80 means what is the momentum? P equal to root over of 1 into 80 meter per second vertical direction, as the mass is 1 kg and the velocity is root 80 meter per second. So this is the momentum kg meter per second. Okay. Right now this component, the along the direction component, will be consumed by this impulse. So this impulse is basically changing the momentum of this direction only. So we can tell that the change in the momentum in this direction is what? 1 into root 80 into cos theta. The value of cos theta, you already know from the previous slide, is 4 by 5. That is, you can write that over 80 into 4 by 5. That means the value will come 16 by root 5 kg meter per second. That is the impulse developed. That is the answer of the first part of the question. I hope it is clear. Thanks for watching.